2, 3. Hey guys, in this video we're going to be doing some more things with e to the x. So just to recap from the last video, I basically said that the derivative of e to the x is the limit, is e to the x is times the limit as h goes to 0 of e to the h minus 1 on h. And I basically said that e is the number such that this limit equals 1, and therefore that would mean that the derivative of e to the x equals e to the x. And in this video I'm basically going to connect that to the fact that e is equal to the limit as n goes to infinity of 1 plus 1 on n to the power of n. So I'll use this fact to prove this fact. But before that, I'll start by showing that the derivative of natural log x is 1 on x, using the fact that e to the x is its own derivative. I'll just clear that. So, we'll start with y equals the natural log of x, and we want to find dy dx as a function of x. We can then take this and we can raise each side to the power of e. So e to the y is e to the natural log x, which equals x because they're inverse functions, they cancel out. And then I'll take the derivative with respect to x of both sides, so d dx of e to the y equals d dx of x equals 1. And we can use the chain rule on the left side to do this. So that will equal d dy of e to the y times dy dx equals 1. And that's actually what we want to solve for, that dy dx. So d dy of e to the y is just e to the y, because remember, e to the y is its own derivative. Hence dy dx equals 1 on e to the y. But from earlier we said that e to the y equals x. Therefore, dy on dx is the derivative of log x, which is equal to 1 on x. Alright, so we can use that fact to help us. So, how should I do this? Right, I'll start with an inequality. That's going to be like 1 minus x squared is less than or equal to 1, which is less than or equal to 1 plus x. Note that x is a real number, and it's greater than or equal to 0. So I'll start here, use the white pen, and we can factor the left-hand side. And just note that the equality happens when x equals 0 anyway. And since x is positive, then this thing is definitely positive. So we can divide through by it without changing our inequality signs. And we end up with this thing. And graphically, it will look like this. So this will be y equals 1. That's that guy. This will be the line y equals 1 minus x, which is that guy. And this will be y equals 1 plus 1 on x, which is that guy. And you can see how this also holds graphically. As a matter of fact, the green and the yellow are tangent. They're tangent over here, but anyway, that's not important. The important thing is we have this inequality. So now we can say n is positive integer. So n equals 1, 2, 3, etc. And later we'll be taking the limit as n goes to infinity. So that's why it's positive. So then what I can do is I can take the integral from 1 on n to 0 of both sides. So over here we have the point 1, and since n is a positive integer, this means that our integral 1 on n will be like over here, and it could equal 1 when n equals 1, but in general it'll be in this range. And from this you can probably see why the inequality holds when I integrate. So we have that the blue is greater than the yellow is greater than the green, but you can also see the blue area is clearly larger than the yellow area, which is clearly larger than the green area. So that's why the inequality stays the same when we do this particular integration. So over here, that's just pretty simple. Now for this middle integral, remember before we had d dx of ln x is 1 on x. Therefore the integral of 1 on x is ln x, because it's ln x is an antiderivative of 1 on x. And similarly, this means this will be ln 1 plus x, because if you differentiate 1 plus x, you'll just get 1 over 1 plus x, and even though there's a 1 plus inside there, it won't change anything. It doesn't affect the derivative chain rule. Now notice when we sub in when we sub in 0, that becomes 0 minus 0, 0. This becomes log of 1, which is 0. And then this will just become 0 to the 1 on n, which is 0. So when we sub in 0, we're just subtracting off a 0, so we can just basically forget about that, and we'll have 1 on n minus 1 on 2n squared less than ln 1 plus 1 on n, which is less than 1 on n. We can now multiply through by n, and n is positive, doesn't change the inequality. And we'll bring this n inside the log using our log laws. And then we can raise each side to the power of e. Oops, forgot our inequality. Now, and notice that, so this side will be a bit less than e because we're subtracting a 1 minus 2n, and this side will be e. But then notice, if we take the limit as n goes to infinity of 1 minus 1 on 2n, this will just equal 1. So the left-hand side will get kind of squished. It will get closer and closer to e. So this would be e. Oh, I don't know how to draw this. That's like e there. That's the middle. And that's the left-hand side. And it will kind of squish it into the e. So basically, what I'm saying is if we take the limit, we'll have e is less than limit goes to infinity of it'll get squeezed between those two other values, and therefore we can say that the limit as n goes to infinity of 1 plus 1 on n, the n is equal to e.